In algebra, we'll come to learn about solving many type of equations, and the process we use to solve a particular equation depends on the type of equation that we're dealing with. In the previous section, we learned about linear equations, and we said a linear equation is an equation of this form where the highest degree of that equation is 1. And we said that we can use several properties of algebra, the properties of addition, the subtraction property of equality, multiplication and division property, as well as a distributive property, to take an equation and transform it from one form to the next until we get the equation to an equivalent degenerative form where the equation can be solved. In this particular section, we're going to learn about equations where the degree of the equation, the highest degree in that equation is 2. And those type of equations are what's called quadratic equations. And there are several methods we use to solve quadratic equations, but before we get into the method, let's try to define what the quadratic equation is. A quadratic equation is an equation in which one of the variable terms is squared or has an exponent, power, or degree of 2, but raised to no higher power. In other words, the highest degree of these type of equation is 2. Some of the examples of a quadratic equation, and it can be written in many forms. Here's an example. It can be written in this form where you have a monomial times a binomial, and could be written in several other forms. However, there is a standard form for a quadratic equation, and that standard form looks something like this. Standard form for a quadratic equation is ax squared plus bx plus c is 0. And there is a little caveat to this form where it says a cannot be equal to 0. And all this means is that if a is equals to 0, then this term essentially is not there. So therefore we would not have a quadratic equation, but we'll have a linear equation. So this condition has to be there in order for this term to exist, so that we have what's called the quadratic equation. Now this is called the standard or general form of the quadratic equation, and even in this form we have several terms. We have this term, which is called the quadratic term. We have also the term with just the x raised to the first power. We call that the linear term. And we also have the term with no x variable, which is called the constant term. The constant term. Now, depending on which of these terms is missing, that kind of gives a lead into which method is advantageous for solving the quadratic equations. You may see some equations where one of these two terms is missing. Of course, in order for it to be classified as a quadratic equation, this term must always exist in the equation. However, one of these two terms can be missing from the equation, and we've seen some examples of that over here where the linear term is missing. We've seen an example as well. We'll see some examples as well where the constant term is missing from the equation. But the quadratic term must always exist in the equation. One of the first methods we're going to get into with solving the quadratic equations is a simple formula that we call the quadratic formula, and it's pretty much just a formula where you plug certain numbers into, and the formula does all the work for you, and you can solve the equation in that way. Let's take a look at the quadratic formula. The quadratic formula enables you to find the solutions to a quadratic equation, and by solutions we mean the zeros, which you will learn in the next chapters, or the x-intercepts for practical purposes. So the quadratic formula is minus b plus or minus the square root b squared minus 4ac, and all of this is over 2a. So if we know the values of B, A, and C, it's just a matter of plugging into the equation. And once we plug those values into the equation, we can solve for the value of our variable. This variable x here can change depending on the type of variable you have in your equation. For these equations, there's variables x running all through them. Some equations have a variable, some equations have z. And as I said, you just change this variable here depending on the type of variable that's in your equation. So let's try to show how this equation is used. Let's say, for instance, if we have an equation x squared plus 7x plus 10 is equals to 0. The key before you can use this particular formula is to ensure that the equation is written in standard form. And all standard form is that all the terms are on one side of the equation, the other side is set equal to 0. Also, you must have the terms in descending order. And if you're missing one of these two terms, then the value for that is considered to be 0. What are the A, B, and C values that are in this particular equation? Well, if you look at the form here, A is always the coefficient of the squared term, B is always the coefficient of the linear term, and C is always just that number that exists in the equation, or that constant term. And again, if we do not have a linear term or a constant term, the values for those are 0, considered to be 0. So when we look at this here, in this particular equation, our A value is understood to be 1. Our B value is understood to be 7, and you want to also pay attention to the sign when you're plugging into the equation. And the C value is also understood to be 10. You can put positive 10, positive 7, just so that you become sign conscious. So once we have our A, B, and C values, which we can only extract once the equation is in standard form. Standard form means all terms are on one side written in descending order, and the other side is equal to 0. Now we can use our formula, which is minus B, whatever that B value is. So it's minus the B value, in this case is 7, plus or minus, which is a part of the formula, the B value squared, so that's the 7 squared. And once you make a substitution, you can use parentheses. For A value is 1, so 4 times 1, and then the C value is considered to be 10. All over 2 times the A value, 2 times the A value, which is 1. So once we simplify this a little bit, I like to simplify this portion underneath the radical first. So it's minus 7 plus or minus the square root of 7 squared is 49, minus 4 times 1 is 4, 4 times 10 then is 40, so 49 minus 40 is that result, all over 2a. And if you notice, 2 times a is 2. I'm doing this in steps because when you try to skip steps, there's a tendency to make mistakes. So let's go ahead and further simplify what's under this radical. So we're going to do that up here. We're going to have, excuse me, I missed my sign there. So it should be minus 7. So it's minus 7 plus or minus the square root of, well, 49 minus 10 is just, 49 minus 40 is just a matter of 9 all over 2. And then once we continue to simplify, we have minus 7 plus or minus, well, the square root of 9 is 3 all over 2. And once we get to this step here, we can rewrite this expression by breaking up the plus or minus situation that's going on here. Here's how we do that. We can say, well, this expression can be written 2 ways. It can be written as x is equals to minus 7 plus version of the 3 over 2, and x is equals to minus 7 minus version of the 3 all over 2. And then we just simplify each quantity here. Negative 7 plus 3, that gives us a negative 4 all over 2, which gives us a result of negative 2. And over here, negative 7 minus 3, that gives a result of negative 10 all over 2, which gives a result of negative 5. So we see our results here is negative 2 and negative 5. We have two solutions of this equation, and we kind of knew that we may have at most two solutions of the equation because we're dealing with a degree of 2. The degree gives us some insight as far as the number of solutions that we're going to have in the equation. Now, is it a situation where we're always going to have two solutions? Probably not. There are some equations where you may not have two solutions, but at most we have two solutions to this particular equation because of the degree here. One of the things you need to do when you're dealing with the quadratic formula, or when you find your solutions period, is you need to check your answers into the original equation to see if both answers satisfy the original equation. So if we were to check our answers into the original equation, x squared plus 7x plus 10 equals 0, and if we want to try the negative 2 first, that's negative 2 squared. Whenever we make a substitution, we use parentheses. Plus 7 times negative 2 plus 10 equals to 0. Negative 2 squared is 4. 7 times the negative 2, that's negative 14. Plus 10 is equals to 0. So this is 4 minus 14. That gives me a negative 10. Plus 10 equals to 0. Negative 10 plus 10, we have 0 equals to 0. Once we have a true statement here, after we plug in the solution, that implies that the answer or one of the solutions satisfies the equation. So it is a valid solution. And we do the same thing for the negative 5 as well. We plug the negative 5 into the equation. We would have negative 5 squared plus 7 times negative 5 plus 10 is equals to 0. Negative 5 squared is 25. 7 times negative 5 is negative 35. Plus 10 equals to 0. 25 minus 35, that gives me a negative 10 plus 10 equals 0. And again, negative 10 plus 10, 0 equals to 0. It's a true statement, which means the solution satisfies the equation. It's a valid solution, so we keep both of them as valid solutions to this particular equations. Thank you.